Cikgu dah boleh mulakan?
Okay. Hi, everyone. Good morning. So today I'm going to discuss something about physics. Okay, so first of all, my name is Miss Amy. And okay, what does physics really make you cry? Too bad because you cannot get away from it because you still need
Cikgu, dengar tak? Sound aku ni kat sini ni. Okay, cikgu, saya dah dengar suara saya sendiri dekat YouTube. So, dekat cikgu lah. Okay, cikgu boleh teruskan lah.
Hello, dengar tak?
Okay, saya dengar.
Kat YouTube dengar tak? Hello? Hello?
Okay, dengar cikgu. Dengar. Dengar YouTube pun dengar. Okay, cikgu boleh teruskan. Saya
Nak sambung balik semula ke teruskan saja?
subjek cikgu menarik. Mungkin boleh mula berawal.
Ada rasa boleh Azan. Kita tak apa. Boleh. Okay, sorry guys, we have few problems. I started all over again. Okay, it's like 3 times I repeated, but it's okay. Okay, is that clear? Is that clear? Can anybody comment? Is that clear? See, anyone can listen to me, right? Okay. All right. Okay, let's start all over again. Okay, first of all, we are going today. Are going to learn something so physics today. Okay, so I'm just gonna skip the first part. Okay, this is the thing about me. Okay, I'm Miss EMI, by the way, and I'm going to discuss about electricity. I have 5.8 years experience. I also teach at a bunch of science subjects, physics, chemistry, biology at different levels, SPM, IGSE, and SPPM. I only focus on these 3 levels. I also teach other bunch of other science subjects, which is Malay, Bahasa, and also Sejarah. The first language I'm going to use is English, and then I also can teach in PM or bilingual. This is my hobby, and this is my life goal. So let's appreciate my drawing. Yes, I drew that this one because that's one of my hobby. Okay, so when I say that we are going to discuss something so electricity, so physics is electricity. Okay, this is the second chapter in physics. All right, so physics, I think I'm just going to just hardest and tedious topics ever in physics, but please don't hesitate. Okay, so let's appreciate the electricity that happens surrounding us, this is the first thing that I love about electricity, which is learning about lightning. Okay, and then we have also in biology in our body, this is the nerve cells sending synapse. Okay, sending synapse towards each other to sending the information by using the nerve impulse, which is the impulse is electricity, and then this is how the electricity is being transported by using the new. Then we also have our electrical power transmission that transferring the electric towards your house. And last but not least, this is the last thing that I really appreciate electricity. My favorite show, The Flash. But you know, the electricity that you can see, why the Flash is running, is not really relatable to the electricity concept. It's just an effect for to see the hero is very good. Okay, so let's appreciate the electricity. As you can see at the previous slide, we really need to learn electricity, even though you hate it so much, but just open your mind, open your heart just to accept it. Okay, so this is the uses of electricity in our daily life. I don't have to explain details in every aspect, everything here. So just appreciate it. This is when you have no electricity at home. This is your reaction, right? Am I right? And last but not least, this is the last quote. Okay, physics is the science of all tremendously powerful instabilities. We also learn about magnetism, electricity, gravity, light, sound. Those are tedious and hard topics in physics, but those are the mysterious of the universe. So you have to be grateful because you got the chance to learn something mysterious about the universe. Okay, first of all, there is in SPM syllabus physics, there is 5 parts in electricity, the contents, but today I'm only talk about the analyzing electric fields and charge flow, and also the second part, analyzing the relationship between electric current and potential difference. Okay, for the first part, which is the analyzing electric, I hope in this topic you'll be able to see the relationship between electron flow and electric current. You can define the electric current, you can describe an electric current, you can sketch electric field lines. This is when involving something sketchy stuff, I really love it. Okay, and then you can describe the effect of an electric field on a charge. And last but not least, you can solve problems involving electric charge and current. So, what is electricity? The question asks you to define the electricity, you just only can say it this way. A flow of electrons around a circuit. Okay, always remember you cannot answer the electricity by just stating a flow of electrons, because electrons only can move in the closed system, in the closed medium, which is we call as a circuit. So you cannot miss the word circuit in SPM answer. Okay, so what actually the flow of electrons? The flow of electrons is basically you need to remember the basic chemistry, which is atom. When atom is reactive, they might donate the electrons from themselves, and this movement of electrons in terms of electricity we call as the flow of electric charge. So electric charge, this is the unit of electric charge, this is coulomb, and also the value or the magnitude of 1 electron, and also magnitude of 1 proton. So what is electric charge? Simply just the product of electron number and the charge of 1 electron. Okay. Basically, all that I'm stating here, this is the usual, the point that might come up in SPM questions, okay? To define the electric charge, to define the electricity, and you need to remember what is the unit of electric charge, and also what is the value of the first of the 1 electron. Okay, so this flow of electric charge actually constitutes the electric current. So, but overall, the real definition of electric current is the rate flow of electric charge. This is the formula. Okay, when we talk about the rate flow in mathematics, it involving per time, something per time, which is charge per time. Okay, so this is the unit ampere, or also sometimes you need to convert the unit ampere to coulomb per second. Okay, because you, in order to get sometimes the value of charge. Okay, and this is the real definition of current. 1 ampere is the fixed current that flows through a wire when a charge flows through the seconds. I cannot see that, you can see at the screen. So this is the conclusion. Sometimes you need to revert the formula, and the basic formula, just remember I equal to P per time. Okay, so what usually question asks you to find out what is the charge in some of the situation. So just revert the formula into this one. Okay, second, where is the flow of electron current and electron? Is that the same direction? Basically, is not same direction. Okay, so as you can see, it flow in opposite directions. Okay, electron flowing from the negative terminal to the positive terminal, while the convection current flowing from the positive terminal to the negative terminal. You can see also at the second figure, for the clear figure. So actually you just noted the flow of electric current, which is positive terminal moving to the negative terminal. Okay, but always remember the flow of electron and also flow of electric current is moving at not the same direction. Okay, why is that so? Just simply there is a lot of explanation about this, so I'm not going to explain detail about this because you're going to learn a lot when you take in physics as in A level, in STPM, or in foundation, or when you further you study in physics, you can learn more about this stuff. But for right now, SPM student just noted that battery the one that causes negative electrons to flow in opposite direction. Okay, you already learned about the first formula in this topic. So let's do the exercise. It's quite simple exercise actually. A car battery can supply a current of 9 ampere for 5 hours. What is the amount of charge? So like I said it at the previous slide, the usually things that the question usually asks is how many the charge? What is the charge? So always revert the formula I equal to charge per time to the Q equal to I. So this is how you revert the formula and use this formula. So simple, just substitute the information after you extract all the information, please substitute it. And remember that bear in your mind, you need to state the units. Okay, every time you try to solve the problem, always state the unit. Okay, every single time. I don't care. I still want you to state the unit every single time. Okay, and then always remember at this situation, we're not going to use the ampere unit, we use the coulomb per second times 5, and remember the standard unit for the time is seconds, so you need to change the 5 hours to 60 minutes and times 60 seconds, and boom, you got the answer. Okay, all right, and the second answer, okay, this is quite tricky question, which is involving the electric charge. Always remember, you need to use the two kind of formula, Q equal to IP, comma, Q equal to N dot electron. So what is N? The number of electrons. This is you're going to find out. Okay, so please revert. You just using mathematical expression, just express the N, and then you substitute the information, the number, the informations, and you got. So always remember, the number of electrons doesn't have any units, so put the word electrons. Okay, next we go further about what is electric field. So this is the sketch of electric field. You need to be able to sketch. So always remember that the positive charge, the lines of electric field is pointed upwards. And how about the negative charge? It pointed towards. Okay. So as you can see, there is a line we call as electric field line, or sometimes we call electric lines of course. This is we know it as a vector quantity. So if you have a strong basic physics, what is vector quantity or mathematics? Vector means it involves magnitude and direction. So it has magnitude, which is the value. Okay, what is this stuff? What is electric field? It's actually a region surrounding the charge, which is experience the electric force. Anything that been put in this field or near to this charge will experience. This is another pattern where involving the sphere charge and also the plate that contains the charge. So when opposite charge, of course, it attracts. It's just like a boy and a girl at different gender, it will attract. You guys like each other, but at same gender, you will repel each other. Okay, this is what we call as a non-uniform electric field. Uniform electric field except at the edge. Okay? So as you can understand, means parallel. Okay, the line is quite parallel, okay, except for the edge. And what about if we have two opposite charges attract each other? So this is how you sketch. Okay, so always bear in your mind about the arrow. The arrow must follow the rule of the electric field of the charge respectively. Okay, this is the last pattern when the two same charges will repel each other. Okay, this is the pattern that you have to be able to sketch. Okay, it's quite easy. It's quite fun to do this. Okay, how about this one? What do you think when we have same negative charge? Of course, they will repel each other, but I want you to draw the arrow. Can you draw the arrow? Of course, the arrow will point inwards. Okay, it will point inwards. All right, let's take a break for a while. Let's appreciate after you learn a few stuff about electrics. So you think that electricity is powerless because of negative charge of electrons, right? So in order to be powerful is to be negative. Just kidding. Actually, the means is it has a hidden message. Okay, do not really absorb the real word that being stated there. But actually, what I'm trying to say, what I try to point out is sometimes when you encounter the negativity in your life, please turn it into power that will light up your life just like if electricity did. Okay, next we move on to the effect of an electric field on charge. So as you can see, we have three figures here. For the first figures, we have extra high tension. Okay, the plane there it is actually the extra high tension, very have high value of voltage, which is 5,000. This one we call as the short form EHT. So what happened when I'm just switch off the EHT? Of course, the ball will look stationary. But why? Because the force exerted on the ball by both plates is equal. As you can see at the picture, is equal at the right side and the left side. Okay. But what happened when I switch on the EHT? It moves towards the positive plate first. Okay. The ball displays to the right, which is it touches the positive plate. Then it will pull up with the positive charge. Then what happened when this right side being filled up with the positive charge? The positive charge will attract or being pushed to the negative plate, of course, because it might attract to the different charges. And then what happens when it already displays to the left, it touches the negative plate and it filled up charge with the negative charge. So it been pushed to the positive plate and the process is going on and being repeated, and that's when we call as oscillation to happen. Okay, next, okay, noted that this effect is usually being asked in SPM, and same goes with this one. Okay, so what happened when without electric field at the first figure? So when you put, we call the HHT, sorry that the flame is actually just normal, just like you saw in the normal flame of the candle. But what happened when I switch on the EHT? The flame started to split into two opposite directions and spreads out. Okay, and the positive have the broadened flame spreads out. Why? First of all, you need to remember that what happened when you switch on the EHD, the heat of flame will ionize the air molecules in surrounding. Okay? And then what happened? It will release the negative charge and the positive charge and become the negative ions and the positive. So the positive ions will move towards the negative plate slowly, and because it's quite heavy compared to the electron, it will occupy the large portion of flame. But but what happened to the negative ion? It will move to the opposite way. Okay? It will move to the positive plate faster because quite lighter and only occupy the small portion of flame because it faster, so it only occupy the small portion because it moves faster because it lighter. Okay, so that's the end of the first part, analyzing electric fields and charge flow. So I hopefully you'll be able to do all these things. Okay, I hopefully you'll be able to achieve all the objectives. Okay, so let's appreciate this GIF, the flash. Okay, just to gain some mood here. Okay, let's move. Are you ready to move on to the next part, which is analyzing the relationship between electric current and potential difference? So basically, what you learned at the previous slide is only the basic of electricity. Okay, you need to understand what is electricity, the electric current, the electric charge, and what is the formula is. Okay, so we move on to the next basic. So in this part, you will be able to define the potential difference. Sounds familiar, huh? And then you can plan and conduct an experiment to find the relationship between current and potential difference. So for the plan and conduct, I'm not gonna explain detail in this slides. Okay, if you want, you can register the online class at pandai.com to find out further at the next slide. Okay, at the next slide from me. Okay, so you can able to describe the relationship current and potential difference. You can state the Ohm's law and define resistance. Explain what is the factor that affect resistance. Solve problems involving potential different current and resistance. And last but not least, describe what is superconductors. It's getting harder. There's so many things to remember, but it's okay. Take a deep breath. Okay, what is potential difference? You need to remember the basic you learned in Form 4, Chapter 2. Not Chapter 2. Yes, Chapter 2. The potential energy. Okay. It is the point, actually, the point where the energy is being stored and ready to transform itself into a different kind of uses of energy. Okay, it's basically like that. Okay, it's potential, or in bahasa keupayaan. Okay, what is the ability? The ability is being restored in energy. So when you drop a ball, the potential energy will transform it into kinetic energy. Okay, so this is actually the law of physics that you really need to remember, because the concept is basically the same as in electricity. Okay, you still remember? If we have force, which is the force being exerted by the girl to drop the ball, and then we have some distance, then we times together, it will form the work done. So actually the work done is equal to potential energy, and this is how you get the formula for potential energy. Okay, you just substitute as you change into high, mg actually is equal to F force. So you just convert and substitute, and then you just derive the formula. Okay, this is another form of potential energy. Okay, it's not only involving the high point, it also can be stated in the spring. Also involve the potential energy. So what is the formula for potential energy for spring? Half kx squared. Okay, so how you derive this? You need to go back. You need to refresh back the foundation, the basic. Okay, this is if you still hesitate or not clear about potential energy, basically potential energy involves the gravity, right? So this is you, this is me. Okay, two people together. Okay, so the point we actually being at different point. So I located at high potential energy because always remember when involving the height, the more height is actually the contain high potential energy. And then if I move towards you, and then which is u is the point of low potential energy, that's when I'm going to transforming the energy into kinetic energy. Okay, so I hopefully you'll be able to absorb got the clear message about potential energy. Okay, so it's actually same with the in electricity, but in kinematics we call as as potential energy. How about in electric? Potential energy is actually equal to electric potential. Okay, so this is positive charge at lower point. This is another positive charge at different point. Okay, quite high point compared to the previous point. So the high point, of course, when it further to the charge, is actually it is actually reverse. Let me. I'm sorry for that. I need to. Okay, sorry for that. I just detect some problem. Sorry. Um. Hi. Okay. All right. So this is actually low electric potential. It's quite different with the potential energy when we expanding in the position of highness. But when we expanding in electric charge, actually we need to be mind about the electric fields. Okay, so when in further with the positive charge, that is where the high electric potential happens there. Then when it further from the negative charge, there is where the low electric potential point. Okay, so I move. This is what we call as potential difference. Okay, we move. Sorry for that, because I thought that this is negative. Okay, kita balik. Okay. So when I try to push the positive at the high electric potential to the low electric potential, that's why we require the work done. So the work done is the potential difference. Okay, so this is another figure. Okay, so high potential, lower potential, and then this is the real meaning of potential difference between 2 points. Okay, 1 volt in 1 joule of work is required to move a charge of column from one point to another. This is the formula, which is potential difference, also known as voltage. Voltage is equal to work done per charge. Okay, so that is the unit. Always mind beware the unit. Okay, so let's do exercise 2. Okay, if this is E actually refer for the electric field, what happened to when I push the B towards A? Okay. So what is the real meaning in terms of potential difference? Okay, so when I push the positive S charge, I push forcefully move towards from point A to B, the work done is required. So potential energy of charge will increase. Because we require work done. Always remember what is potential energy again? The work done that been required. So when we require the work done, that's when the potential energy of charge will increase. PE stands for potential energy. Okay. Same goes for this one, the positive charge will naturally moving. Okay, at the previous figure, actually it will forcefully move, so that's when the potential energy charge will increase. But here, the positive charge will naturally move in at negative field. Why? Because it will naturally move towards move away from the positive charge. Okay, so the work done is not required, and the PE of charge will decrease. So when you answer this kind of question, it usually come out in objective and also subjective. Always remember about the arrow of electric field. Okay, so this arrow actually determines whether the potential energy of charge will decrease or increase. Okay, before that, you always need to determine where the movement of the point from A to B or B to A. Okay, so how about this one? So from the previous slides, talking about the positive charge. So from here, we're talking about the negative charge. So the positive charge will naturally move into the electric field. Why? Of course, again, remember the electric field of the arrow of electric field of the negative charge is point towards. So it's quite easy to push from A to B. So work done is not required, and then the potential charge will decrease. So what happened if I forcefully push the point from B to A? Okay, we forcefully push, so the work done is required. So potential energy of charge will increase. So this is actually quite common in SPM. So the conclusion is potential energy, just simply we can say, is equal to voltage. The difference between Q and P and can be using the device of voltage measurement. And then usually the symbol is a V. And then we have higher potential, which is from the positive towards the negative, okay, as you can see. All right, so let's do this exercise. Okay, you already learned the third formula of potential difference. There is the current flows through an electric heater for 40 minutes. Just remember, 40 minutes need to be converted into seconds. So it needs to times with 60 seconds, which is okay. Then we have current, which is 6.0 ampere, and then the heater will convert the energy. This is electrical energy into heat energy. So you need to find the total charge that's circulated through the heater, and also you need to calculate the potential difference of the heater. So for the first thing you need to do, you need to find out the total charge that's circulated. So it's quite easy. Just use this formula that you learned at the previous part, the first part. Okay, simple. Just substitute the information, and then you will get the answer. And always remember to convert the 6.0 ampere into 6.0 coulomb per second. Yes, I really actually concerned with the way how you write up your answer in SPM. Okay, because examiner just want to look at a very clean and precisely the way of you answering the questions. Okay, so please bear in your mind that change what you need to be changed. It just don't left it undone. Okay, this is the potential difference. How to find out the potential difference? V equal to W per charge. Okay, W is work done. So where is work done? Okay, can you find out the work done? This is the work done times. Okay, I'm actually there's a wrong. If you can find out there's a wrong, it's supposed to be divide. Sorry for that. So the answer is actually this one, but the symbol should be divided, not times. Okay, let's go further with the Ohm's law. Sounds familiar with Ohm's law? Okay, Ohm law stating that electric current flowing through a conductor which is proportional to voltage and inversely proportional to resistance. Okay, when we say that proportional, this is the symbol of proportional, just like a ribbon, you need to convert into equal. So when equal, of course, there is a constant, which is who acts as a constant? Resistance acts as a constant. Am I right? Of course, resistance acts as a constant. Okay. So this is the formula for the Ohm's law that involving the Ohm's law. And there is the symbol of resistance. Okay. Let's appreciate the graph. Okay. When you have the linear graph, because it's proportional, it must be linear graph between the current and voltage. This is where we say that this is the ohmic device graph. But when it not obey the linear graph, we call as non-ohmic devices graph. Okay, so always beware and be mind about the type of graph there. Okay, so I know if some of you might wondering what is electrical conductor. It is simply a substance or medium that can carry the electrical charge. So which is electron of course, and it can move easily the charge from one atom to atom with the application or the existence of voltage. Okay, so simply it is actually just an object to transferring the electron from one point to another point. Okay, so this is the formula involving the Ohm's law, you always think the first formula. So use this concept with the triangle concept. Okay, actually, it's not really necessary for you to remember this triangle concept. If you're a mathematics student, it's quite easy. Just express whatever the alphabet or the subjects that you want to find out, right? You just express it. Okay, next we go, what is resistance? Resistance is simply a ratio. Always remember that it's a ratio. Okay? A ratio of potential difference across the conductor to the current that flowing through the conductor. Okay, so the unit is voltage per ampere, or we can simplify as an ohm. So why unit? Why I stated two types of units? Because you need to wear these two units. Sometimes you have to use the volt per ampere. Sometimes you need to use the ohm unit. But of course, usually we use the ohm unit. But in some circumstances, some current situation, we need to actually use the ohm unit to the voltage ampere in order to get the ampere unit or the voltage unit. So this is simple that explaining the visual, that explaining details about what is resistance. Okay, simply a current can only flow a few electrons, and then there is a resistance there. In every conductors actually has its own resistance. Always remember, if in some circuit there is no conductor, that we will provide the conductor. Not conductor, the resistance, okay, which is called resistor, the electronic device for resistance. Okay, so this is the formula. Again, you see the triangle explanation to express the R subject. If you get the formula, this is the symbol for resistor. Or another symbol, if you're quite familiar, something like this. So it depends whichever symbol that you want you to use is actually the same meaning. Okay. All right. Actually, there is involved four factors that affect the resistance of a conductor. So if you want to find out more, and of course you need to learn more in SPM, you can register online my class. I will explain detail what is the four factors that affect the resistance of a conductor. Okay, and of course you can always you can always request for me to explain in BM or explain in English or bilingual. Okay. So again, what is resistor? As you can know, that resistor just now is actually the one that provides resistance. Okay, this is the resistor, the electronic device of. This is another form. Okay, what is resistor? Just an electrical component that limits or regulates the flow of electric current in electronic circuit. As you can see, the previous figure, which is if we have hands that push the electrons backwards, but some of the electrons might escape. Okay, so it only allows limits or it controls the flow of electric current. It's quite easy to remember actually. Resistor stand for resistance. Okay, resist, menahan. So it only allows some electrons to pass through it. Okay, so anything that electricity cannot travel through easily, we call as a resistant or resistor. Okay? When electricity is forced through a resistor, the energy in electricity is changed into another form of energy, such as light or heat. This is when the situation happens when we put the metal in our circuit. This is how the lamp lights up. Okay, the light bulb is switched on. Okay, because of the resistance, there is kind of energy is actually being transformed into another form, which is light or heat. Okay, this is the way how it works. Okay, the transistor in the light is a resistor. Electricity can pass easily and convert it to light energy. So the funny thing, the metal acts as a resistor. So the resistor can be anything, but basically in real life, in industry, we usually use this common type of resistor at the left side figure. Okay, the copper wire conducts electric efficiently. So the copper wire actually acts as a conductor. So anything that can allow the electric charge or electric current to pass through easily, we call as a conductor. Okay, so conductor is always opposite of a resistor. Okay, all right, we move further with the exercise. Okay, this exercise is quite simple actually. It's not that hard. So if you still remember the formula, yes. Before that, extract first the information. We have resistance R, we have potential difference, and we have this formula. So you already can use this formula and just substitute the number and boom, you will get the current. Okay. So next, what is superconductor? Alright, students, my fellow viewers, all my viewers, I'm not gonna explain detail of superconductor. You need to find out in the online class, my online class. So you can register at pandai.com to find out more about superconductor. And if you're really interested in learning the electricity from me, you can always register my online class at pandai.com. Okay, so please, you can always register by using this web link. Okay, do you still hate learning electricity? Yes, I got a lot of complaint actually from not only a physics students but common people, common students, common people, most of them actually complain how hard it is to learn the physics things, which is some of that is electricity. Okay, by Nikola Tesla, let's appreciate the quote of Nikola Tesla. Why? Who is Nikola Tesla? If you don't know him, find out about him. That's the way how you appreciate physics, and that's the way you trick your mind to learning physics more precisely. Okay, if your head could be turned into electricity, it will light up the whole world. Funny, huh? You hate electricity, but the electricity is the one who light up the whole world and your life. So please don't hate electricity. Or maybe you still can hate learning electricity, but find out the challenge as a love. Okay? The challenge of learning electricity as a love. Okay? It's like I hate you, but I love you. Okay? Something like that. Okay, so this is another quote that involving this topic. Okay? A matters of stars swim with the current matter of pressing to stand like a rock from Thomas Jefferson. Okay? This is the way how I learn, the way how I appreciate science subjects, the way I learn or score. You need to find out the heart of the science, okay, by understand the quotes, okay, the means. Okay, this is the way you do it. Okay, so last but not least from the class, do not waste electricity. How would you like if your best friend, your lover, turn you on and walk away from you, just like you did with electricity? So please do not waste electricity. Appreciate, do not take for granted with everything that we. So that's only from me. So hopefully we will see at the next webinar. If you're interested to see me to teach another subject, you can always subscribe. You can always register the online class, and also you can watch at the webinar because it's free. You can test from there if I switch to teach all the other subjects. Okay, so that's all from me. So I hopefully you'll be able to learn something not only physics but about life. I hope it motivates you to achieve more in your life, to accomplish more in your life. So that's it from me. Assalamualaikum and good morning, guys. So you can do whatever you do, the next thing you want to do.